Hi my friends, today we model this part, which is difficult mostly because of the application of this physical real thread. This is the drawing, and you see that here is a texture, not a real thread. Why? Because this is made with Inventor, and Inventor, Autodesk Inventor, has this property to apply such a nice texture and imagine the real thread. We have to discuss some aspects about this because we work with FreeCAD. You see here the name of the thread, gauge 1/4 inch. Working with FreeCAD, we will want to generate a solid with a real thread so that the part can be physically obtained by 3D printing. But before, I want to mention that this is the number 20 model of my collection of 100 mechanical parts. There are two definitions, BSP for British Standard Pipe and NPT, National Pipe Thread. This is British and Australian and Commonwealth, and this is American Standard. So we have 1/4 with this definition, and here is another one. We work with this one, and if you live in America, you have to study this definition. For 1/4, you have to keep in your mind the pitch in millimeters, 1.337, major diameter 13.157, the minor diameter is this one, and you have how many threads the part has per inch. Here is 19. Keep in mind that you can always find many data, as you can see here, by using this link. You can download a lot of data. General index table is for Autodesk Inventor. FreeCAD has another file, Excel file, to find every tutorial with this software. You can also download something interesting, threads for pipes and metric tap size chart for metric threads. Don't ignore and download them anytime you need to see tables with threads. I made a graphic presentation for this kind of thread. You see here dimensions D1 with dimensions for 1/4, H1, pitch, the angle, this is 55 instead of 60 for European DIN threads, and this dimension of H plus this one, which is a difference between these two. We have some expressions. H1 is simply to be understood. 0.856. The radius R, this one, is obtained by dividing 25.4 millimeters per the number Z of the pitches per inch, which is 19. The dimension H comes from this triangle with all dimensions. You have to use this expression to obtain the value if you need it. We start by creating this revolving volume with dimensions 25, diameter of 11, diameter of 10.5 on 2 millimeters, 9 and 18. This diameter will be the internal diameter of the thread, which means this dimension D1, this one, of 11.445 millimeters. We start with an empty document and we create a new sketch. Take care of this workbench, part design, and to this option of CAD instead of Blender, because we create mechanical parts. We use this plane and we draw lines, polylines, starting from here to the right, up, left, down, left, up again. We go here and back to the start. This is not vertical. I select it and I apply vertical. Dimensions. This is 2 millimeters. This is 9. The distance to the center is 18. And the hole is 25. Diameters. This is 10.5 divided by 2. This is that dimension of 11.445 divided by 2. And this last one is 11 divided by 2. Good. We apply close because we have fully constrained sketch. And we apply revolve. We have to select the x-axis. Okay. Now we have the first volume. Next is this feature. We have here all dimensions: 10 diameter, 12, 5.5 and 8.5. Another sketch based on the same plane, and I use this section view because I want to see the center point. Why? Because we create a polyline starting from here, up, left horizontal, down vertical, right, down, and back to the start. You see the constraints here, everything is okay. So we place dimensions. This is 5.5. This from the point to the center point is 12. Then we have a diameter of 10, so we apply 10 divided by 2. And also this is 8.5 divided by 2. We have a fully constrained sketch, close and revolve. Now you see we have this axis as default. Okay. We continue with this hole, diameter of 5, ending to the center point plus half of 5. Yes? 12 plus half of 5. We know the procedure. We select this, we take it as a sketch, and we apply a circle with this center and not diameter precised, because we use hole, and hole is with default of 6. We have to place 5 instead of 6. Then we apply the dimension of 12 plus 5 divided by 2. Okay. Now we see chamfers 0.5 to the hole, to the upper edge, bottom edge 0.5, and also 0.5 here. We press the Control key and we select edges 1, 2, 3, 4. Chamfer, and the dimension is 0.5 for all of them. Okay. Now we have to create this cut. Dimension 3.5 on 2. New sketch, the same plane. We see inside, then we project this line. We create here a rectangle with dimensions 3.5, enter, 2, enter, not tab. Yes. Then we make symmetrical these 2 points about this axis. We have again fully constrained sketch, and we apply pocket symmetrical with dimension through all. Okay. The other hole is this one with a countersink. Diameter of 5, diameter of 8.5, and angle of 20 degrees. The depth is 18 plus half of 5. We select this face, a new sketch with a simple circle with an arbitrary diameter, close, and hole. The hole is 5 millimeters. The depth is 18 plus 5 divided by 2. Then we go down to hole cut type, countersink. We place here the diameter of 8.5, and the angle of 20 degrees. Okay. You see how it looks inside. We continue with creating this profile, only one pitch. This dimension is equal to this dimension. The pitch is this dimension. Then we have to place this point at the start of the thread. This dimension is already placed on the model, the right cylinder, and we use this radius to be subtracted from H1 in order to draw this arc, or this arc. H1 is this expression with this result, and the radius is here, as you already know. Let's use all this to create only this profile. We create a new sketch on the same plane. You know that this is 2 millimeters. We project this line, and we start with a polyline from here up, triple M, MMM, to obtain this arc. Then we go down, MMM, and we select this point. Right click, and starting from here we create another MMM, this arc. We know that these 2 points are on the same vertical. Then we make equal this arc with this arc, and also this with this. Then we move a little this to place it on the same vertical, this point with this end point. On the same horizontal now, this point with this point. Then we draw a line to connect that two ends. Good. Now I place equal for these two lines. Now we can start with dimensioning. We can verify some things here. It is a robust construction, and I start with the pitch of 1.337. Okay, then the angle of 55 degrees, the radius of 0.1835, and the last dimension between this point and this line of 0.856. This is H1 minus 0.1835, and this is the radius. Okay, now we have a fully constrained sketch. Close, and you see that sketch here. Now we use a new tool, additive helix. Click on it, and now we have to wait. This is nothing for what will be. This is not what we want, but this is because the z-axis is by default. We select our axis, x-axis, and we wait. No long time. Good. Now we place our data. The pitch is 1.377. Then you see this is now stretched. This is the height, which is the dimension on the x-axis of our thread. We know that this is 9, and we also know that this is outside of 9. So we place here 15, for instance. We wait now to obtain that 15. Good. Okay. You will decide for yourself when it is appropriate to use this physical thread solution, choosing it only when you want to apply 3D printing. Now we have to eliminate this few threads by using this face. I select the face, I apply datum plane, and I create a large sketch in this plane. Okay, select this, apply sketch, wait. You always have to wait. Then you draw a large circle, this one, no matter what is the diameter, and close. We wait, yes. Now I apply pocket of this circle to one direction, right or left. Right, okay. You see, everything is okay. Okay. We wait. Now we wait to end this cut. Now we hide the datum plane and we go further. Now we have to apply a similar solution to cut this last thread. To do this, we select this face, click on it, and datum plane on that face. Okay. Now let's see the great picture. We select this datum plane for a new sketch. We wait a little, then we cut the face and we have this face. We project this circle, this larger one, and we draw a circle with that dimension. Another circle with a larger diameter is this. Close the sketch. And we have the two circles. They can be used for a pocket. We wait again. We don't want to cut to the right, but to the left. To the left is reversed. We wait again. We don't want 5 millimeters, but 2 or less. 1.5 is larger than the pitch 1 and 4. Okay. We wait again. We hide this datum plane, click here, and you see the result. Let me see what is this dimension. It is 2 millimeters is okay. Yes, it is 3 millimeters. Good. There are two chamfers, 1.5 at 45, 0.5 on 45. We have to apply this by using revolving, not a chamfer tool. New sketch, the same plane. We wait as usual, and we can create a new sketch. We project this vertical line and we draw a triangle. Down, vertical, left, and horizontal. It is not horizontal, we make it horizontal. Then we align this with this point, coincident this line with this point. We make equal these two entities because we want to have 45 degrees. Then we apply that dimension as an expression. The distance between this and the center point is 13.157 divided by 2 minus 1.5. Okay, good. Close. And we apply groove. Groove about what axis? Not vertical, but X. Now you see the cut. Okay. We wait again. Same procedure, but we use other dimension, 0.5 instead of 1.5. We project now this line. We draw a triangle, horizontal, vertical, equal the two, then coincident this line with this point. We enlarge this and that dimension. The dimension from this point to the center point on horizontal here with 13.157 divided by 2 minus 0.5 instead of 1.5. Okay. Close. We wait and we apply again groove. And we select again the X-axis. Okay. Now you see this chamfer to the left and this chamfer to the right. Good. That's all for today. Thanks for watching. Bye bye.